Have you ever looked in the mirror or maybe felt a certain ache and thought, well, this is just my genes, my destiny, my family's history playing out? It's a really common belief, isn't it? That our health path, our lifespan, even maybe how gracefully we age, is all kind of pre-programmed in our DNA, leaving us with, well, maybe not much control, like we're just reading a novel that's already been written right to the end.
Hmm.
But what if that wasn't the whole story? What if the latest science suggests something actually far more empowering, a narrative where you hold significant sway over your health and how long you live, and crucially, how well you live? That's really our mission today on the Deep Dive. We want to unpack the complexities of human longevity, moving way beyond that simplistic and honestly often disempowering idea that our genes are our sole destiny. We've gathered a fascinating stack of cutting edge research papers, some really in depth studies from leading institutions, and expert analyses to guide us through this conversation. We're going to dive deep into what actually drives longevity.
And that's exactly what we'll do. Because while genetics certainly play a role, I mean, they give us a certain predisposition, a starting point, if you will. What we're discovering and what these sources really powerfully reveal is how deeply our environment and our daily choices interact with those genes. They shape not just our lifespan, which is, simply the total number of years we live.
Great, just the number.
Exactly. But critically, they shape our health span. And health span, well, that's defined as the number of years we live in good health, ideally free from chronic illness or debilitating disability. It's such a vital distinction because, really, what's the point of living longer if those extra years are just plagued by illness and, frankly, a diminished quality of life?
That makes perfect sense. Quality over just quantity.
Precisely. And consider this really striking statistic. The World Health Organization states that chronic diseases are the cause of 74% of deaths globally each year. 74%.
Wow, that high.
It is. That means roughly 3 out of every 4 people worldwide die from a chronic illness that could potentially have been prevented, or at least significantly delayed. And what's truly profound here is that if such a high percentage of deaths are from potentially preventable conditions, it dramatically redefines what old age means for most of us. It suggests that for the vast majority, true longevity isn't about somehow escaping a genetic expiry date that's fixed at birth. It's really about actively managing, delaying, or maybe even avoiding those preventable conditions. Your health span isn't just like a part of your lifespan, it's the lever for a longer, higher quality one. The quality of our years really does directly influence the quantity.
That's a really powerful reframing, isn't it? Putting the emphasis squarely on health span, on the quality of those years. So, okay, let's unpack this idea of genetic destiny then. For a long time, the prevailing wisdom, maybe fueled by some earlier research, it really felt like our genes were this fixed blueprint, almost an unchangeable fate. What does the latest research particularly say, those compelling twin studies and these huge population data sets, what do they really tell us now about how much our genetics truly determine our lifespan? Because there's certainly been some evolving thought on this, right?
Oh, absolutely. The understanding of lifespan heritability has been quite dynamic. It's undergone some significant revisions over the years. Initially, some high-profile reanalyses of twin study data, they actually proposed a surprisingly strong genetic influence.
Right, I remember hearing about those.
Exactly. These studies theorized that if you could somehow mathematically remove what they called extrinsic mortality, so deaths from things like accidents or homicides or acute infections that aren't really linked to a person's intrinsic biological clock.
Things from the outside, basically.
Right, external factors. If you could remove those, they estimated the heritability of our intrinsic lifespan, our sort of inherent biological longevity, could be as high as 50 to 54%. And that perspective really fueled a popular idea that our genetic potential for a long life was largely predetermined and quite strong.
Okay, so over half,
Yeah.
potentially.
That was the initial thought. However, then came the counter-argument, often from even larger-scale analyses. These researchers look at really extensive family pedigrees, tracing family trees over many generations, and they argue that those previous estimates were actually significantly inflated. They pointed out that social and environmental factors just weren't adequately accounted for in the earlier analyses. A crucial element here is something called assortative mating.
Assortative mating, what's
Yeah.
that exactly?
Well, think of it this way. People don't just randomly pick partners, right? We often gravitate towards those with similar backgrounds, similar lifestyles, similar habits, and that often includes health habits, socioeconomic factors, even educational levels that influence health and longevity.
Okay, like attracts, in a way.
Pretty much. So if healthy, active people whose families tend to live long happen to pair up, Their children will naturally inherit both their genes and likely be raised in a healthy, supportive environment. This can make it look like genetics are everything, when really, shared lifestyle and environment are powerful, often overlooked factors that get passed down alongside the genes.
Ah, so it muddies the waters between nature and nurture.
Exactly. And when you adjust for such confounding factors, the true heritability of lifespan, according to these more recent, larger studies, may actually be well below 10%.
Wow, from over 50% down to less than 10%. That's a staggering reevaluation.
It is a dramatic shift, isn't it? It profoundly recalibrates our perception of the power of genes alone.
So, what does this recalibration mean for how individuals should actually think about their personal genetic risk or, their family history of longevity if genes are potentially such a minor factor in the grand scheme?
Well, it fundamentally means we have far more agency, far more control than we previously thought. And to really solidify this point, look at a very compelling study from the University of Oxford. They utilized data from nearly 500,000 participants in the UK Biobank. That's one of the largest and most comprehensive biomedical databases in the world.
Okay, massive data set.
Huge. And what they found was quite striking. Environmental factors explained a full 17% of the variation in the risk of death among these participants. Meanwhile, genetic predisposition, as we currently understand it from known genetic markers, explained less than 2%. Less than 2%.
17% environment, less than 2% genetics.
Yeah.
Yeah, that's a direct contradiction to the it's all in your genes idea.
It really is. It's data-driven evidence highlighting that our external world and our daily habits have a far greater statistical impact on our longevity than our inherited predispositions, at least based on what we can currently measure genetically. And the Oxford study went further. It identified specific environmental factors with the most significant impact on mortality and biological aging. For example, smoking, a clearly modifiable behavior, was associated with 21 different chronic diseases, everything from various cancers to cardiovascular and respiratory illnesses.
No surprise there, but still staggering.
Absolutely. Then socioeconomic factors, things like household income, whether you own your home, employment status, these were strongly linked to 19 diseases. It really points to the profound impact of what we call the social determinants of health.
Right, things beyond individual choice sometimes.
Exactly. And physical activity, which we'll definitely dive into later, was associated with 17 diseases. But the good news, and this is really crucial, is that 23 of the factors identified in this study are considered modifiable.
Okay, so things we can actually influence.
Precisely. This means we have direct agency over them. They are not fixed aspects of our lives. The study also highlighted something interesting, that early life exposures, like your body weight when you were 10 years old, or whether your mother smoked around the time of your birth, were shown to influence an individual's aging process and their risk of premature death 30 to 80 years down the line.
Wow, decades later. That really shows the long shadow early environment can cast.
It does. It impacts cellular health and disease risk decades later. And ultimately, studies of individuals who live exceptionally long lives, centenarians, supercentenarians, they reinforce this perspective. Their most significant commonalities are not primarily unique genetic markers that we found, but rather shared behavioral patterns. They are overwhelmingly non-smokers, they are generally not obese, they tend to manage stress effectively, and they maintain healthy habits that delay or avoid the onset of chronic diseases.
Which, as you said, are the main cause of death anyway.
Exactly. Their shared environment and lifestyle choices seem far more predictive of their extreme longevity than any specific longevity gene we've been able to pinpoint so far.
So we're not just passive recipients of our genetic code, are we? We're more like active programmers of our biological destiny. This idea of, turning on the beneficial software for our bodies. It's incredibly compelling, but maybe also a bit overwhelming for some. Where do we even begin to translate that kind of molecular agency into daily actionable steps? And how exactly do our choices and environment communicate with our DNA to have such a profound impact? It's not just a general influence, is it? There must be a specific biological language at play.
You're hitting on the core mechanism, and that's where epigenetics steps in and becomes truly fascinating and absolutely central to understanding longevity. Epigenetics is essentially the science of how our specific lifestyle choices can modulate gene expression, meaning whether genes are turned on or off or dialed up or down without actually changing the underlying DNA sequence itself.
Okay, so the DNA code stays the same, but how it's read changes.
Precisely. Think of our genes as the fundamental hardware, the static blueprint, the raw code that rarely changes throughout our lives. Epigenetics, on the other hand, is like the dynamic software. It's the set of instructions, the updates, the patches that tells that hardware what to do. It decides whether specific genes, those lines of code, are switched on or off, whether their volume is turned up or down, how strongly they are expressed.
Like adjusting settings.
Exactly like adjusting settings. A healthy diet, regular exercise, managing stress, these are all effectively software updates or patches that can tell your genetic hardware to run more efficiently. They can activate pro-longevity pathways or even help silence genes linked to disease, all without altering the underlying DNA sequence itself. It's this dynamic layer of control above the DNA.
Fascinating. So what are the actual mechanisms? How does this software update happen?
There are a few key mechanisms we understand pretty well now. One is DNA methylation. This involves adding or removing tiny chemical tags, specifically methyl groups, directly onto our DNA molecules. Imagine these tags like dimmer switches for gene activity. If a gene's promoter region its on switch gets heavily methylated, that gene might be dimmed down or even completely turned off. If it's demethylated, it can be brightened or turned on.
Okay, chemical tags acting like switches.
Right. Another key mechanism involves histone modifications. Histones are proteins that our DNA wraps around like thread around a spool. How tightly that DNA is wound around these histones matters a lot. If the DNA is wound very tightly, the genes in that section can't be easily read or expressed by the cell's machinery. If it's looser, they become accessible and can be expressed. Lifestyle factors can influence how tightly or loosely the DNA is wound.
So changing how accessible the genes are.
Exactly. And beyond these, there are these fascinating tiny molecules called microRNAs or miRNAs. Think of them as master regulators. They're incredibly small pieces of RNA that don't actually code for proteins themselves, but instead they fine-tune which other genes get turned on or off and how strongly. Research now clearly shows that age-related changes in how these miRNAs are expressed contribute directly to things like systemic inflammation, neurodegeneration, and metabolic dysregulation, all hallmarks of aging.
Wow, tiny molecules with huge impact.
Absolutely. Some, like a specific one called miR34A, are even identified as key regulators of specific aging pathways. And we're finding that specific circulating miRNAs in our blood can even be predictive of cardiovascular aging, showing their immense potential as biomarkers for our biological age and health. It reveals a direct, powerful link between these tiny regulators and our long-term health.
So how do our choices actually influence these epigenetic mechanisms?
Well, our sources provide a pretty clear roadmap, showing how specific lifestyle choices can profoundly modulate gene expression through these mechanisms. For example, exposure to certain environmental pollutants, like aromatic hydrocarbons, think benzene from vehicle exhaust, or industrial emissions and other persistent organic pollutants like PCBs or DDT, has been consistently associated with altered DNA methylation patterns in our blood cells.
Like pollution literally changes these tags.
It seems so. These changes can manifest as, for instance, a reduction in methylation on certain repetitive DNA elements called line 1 and ALU, or hypermethylation, too much tagging, in tumor suppressor genes like P15, and hypomethylation, too little tagging, of cancer antigen genes like MAGE1. Worryingly, these patterns can sometimes mimic those found in malignant or cancerous cells. It illustrates a direct pathway through which external toxins might negatively influence our internal cellular machinery via epigenetics.
That's quite concerning. But what about positive influences, like diet?
Absolutely. Diet plays a hugely significant role in shaping our epigenome in beneficial ways. Dietary nutrients like folate and the B vitamins, particularly B6, B9, which is folate, and B12, are absolutely essential for proper DNA methylation. They act as crucial cofactors in the chemical reactions that add those methyl tags. Without enough of them, our epigenetic machinery can falter.
So getting enough B vitamins is key for this software.
It's certainly a key component. And then there are beneficial compounds like polyphenols, which are found abundantly in things like colorful berries, green tea, and high-quality dark chocolate. Along with omega-3 fatty acids from fish or flax seeds, these can influence those histone modifications we talked about. They can essentially tell our genes to either express more protective proteins or to actively reduce inflammation. Selenium, for instance, a trace mineral, can actually reactivate certain silence genes by modifying both DNA methylation and histones. It highlights how specific nutrients can really fine-tune gene expression for the better.
And exercise, does that affect epigenetics too?
Profoundly. Exercise, something we often think of just for muscles and heart health, has immediate and significant effects on the epigenome. Regular physical activity can induce favorable changes in DNA methylation in genes related to metabolism and muscle growth, literally optimizing how our body uses energy and builds tissue at the genetic level. It can also activate a key gene called SERTNID1, which is deeply involved in cellular repair pathways and stress resistance. Think of it like a master switch for longevity pathways.
The same certain I1 mentioned with fasting.
Exactly the same one. Exercise can also boost the expression of genes that enhance mitochondrial function. Remember, those are the powerhouses of our cells that produce energy. But what's particularly exciting and truly revolutionary about epigenetic alterations, unlike fixed genomic mutations that are hardwired into our DNA,
Yes.
is that they can be reversed. Imagine that. Your body's software isn't set in stone. It's constantly updatable through your choices.
That's incredible. So mistakes aren't permanent, epigenetically speaking.
To a large extent, yes. This isn't just about avoiding bad habits. It's about actively promoting the good code for health and longevity. This dynamic reversibility makes epigenetics an incredibly promising target for actively delaying aging and extending our health span.
So this really shifts the perspective. It means we have real, profound agency over our health right down at the molecular level. It's not just about, avoiding bad habits, but actively promoting good gene expression, turning on that beneficial software for our bodies. That's incredibly empowering. Building right on that, let's talk about something many of us focus on daily: nutrition. We are constantly bombarded with the idea of miracle superfoods that promise to extend our lives, to be the one magical pill, just, in a different edible form. You see the headlines all the time. Eat this one thing and live to 100. What's the actual reality behind these often exaggerated claims? Is there really one single food that can truly do it all for longevity?
It's a very compelling idea, isn't it? That single superfood as a magic bullet for longevity. A simple shortcut to a longer, healthier life. Who wouldn't want that? But the science, unfortunately, largely debunks this myth. A great example of this hype versus the reality is acai berries. They really exploded onto the scene a while back with claims of immense antioxidant power and amazing anti-aging benefits.
I remember that. They were everywhere.
They were. And our sources indicate that while acai does show strong antioxidant effects in preclinical studies, so we're talking in test tubes, isolated cells, or maybe animal models, the benefits for humans are simply not as consistent or profound as often advertised.
So good in the lab, but maybe not so much in real life.
That seems to be the case, or at least it's much less clear-cut. There are also practical warnings that consumers really need to be aware of. The National Center for Complementary and Integrative Health, NCCIH, which is a reputable source, specifically warns about many drug interactions with acai. That can be genuinely dangerous if you're taking other medications. And then there's the concerning issue that some acai supplements may not contain acai at all, or contain very little, meaning you might not even be getting the active ingredients you think you're paying for.
Wow, okay. So buyer beware.
Definitely. And to illustrate the lack of consistent human benefit, one clinical trial found that daily acai pulp intake for a substantial period, 60 days, did not significantly alter key lipid profile measures. Things like total cholesterol, LDL, bad cholesterol, HDL, good cholesterol, VLDL, or triglycerides when compared directly to a placebo group.
So no major effect on cholesterol in that trial.
Right. Now, another study did find that an acetate-based smoothie significantly reduced post-meal oxidative stress markers compared to a control. But that was a single-dose study looking at just one specific marker right after eating. So while there are some interesting biological properties there that certainly merit further research, the overall picture for significant, consistent, and broad human benefits for longevity is far less clear than the marketing hype would suggest. We're simply not seeing widespread dramatic effects on lifespan or health span in rigorous human trials.
Okay, so if it's not about finding that one magical food to sprinkle on everything or, swallow in a capsule, what is the science-backed approach to diet for longevity? What kind of comprehensive dietary patterns should we really be focusing on to unlock those epigenetic benefits we were just talking about?
You've hit on the key word there, pattern. The science overwhelmingly shifts the focus to the power of a balanced, diverse dietary pattern, rather than getting bogged down fixating on any single ingredient. And the Mediterranean diet really stands out as a strong, scientifically supported example for enhancing both quality of life and longevity. It's not just a list of foods, it's really a lifestyle pattern.
Right. I've heard so much about the Mediterranean diet. What makes it so effective?
Well, its composition is key, and it's quite balanced. It typically involves moderate amounts of wine, often with meals, and moderate amounts of lean meat. But the real emphasis is on large, consistent amounts of fish, high-quality olive oil, plenty of nuts, legumes like beans and lentils, whole grains, and just an abundance of fresh vegetables and fruits.
Lots of plants, healthy fats, fish.
Exactly. And our sources detail its impressive holistic health benefits. It actively promotes better immune function and supports gut health, which we're increasingly recognizing as absolutely central to overall well-being. It delivers a really rich array of essential nutrients, things like dietary fiber, a vast spectrum of polyphenols, those plant compounds we mentioned, vital omega-3 fatty acids, and a broad range of antioxidants. It's also been shown to significantly improve insulin sensitivity and blood sugar regulation, which is particularly crucial for individuals managing or at risk for type 2 diabetes.
Okay, so good for metabolism too.
Very good. And crucially, it's consistently linked to lower risks of various cancers, including breast and colorectal cancers, metabolic conditions like obesity and metabolic syndrome, and significantly reduces the risk of cardiovascular disease, which, as we know, remains a leading cause of deaths globally.
Yeah.
But it goes beyond just physical health markers. The Mediterranean diet is also associated with improved physical, mental, and social well-being. It leads to an enhanced health-related quality of life, or HRQLL.
Quality of life. Yeah.
Right. Studies even show its positive effects might be more pronounced for older individuals and for those who already have healthy cardiometabolic profiles, suggesting it really helps maintain good health as we age, rather than just, say, reversing severe illness.
Mm.
It's also remarkably adaptable. It's proven successful even for non-Mediterranean populations who simply adopt its core principles: more plants, healthy fats, lean proteins.
So you don't have to live by the Mediterranean Sea to benefit.
Not at all. Interestingly, social factors like higher social capital, more community engagement are strongly associated with better adherence to this diet and improved quality of life outcomes. This reinforces that it's not just about the food itself, but perhaps also the social context and the mindful approach to eating often associated with that lifestyle.
That makes sense. It's a whole package. Now, within that pattern, are there specific foods that stand out? You mentioned kale earlier.
Right. So while no single food is that magic bullet, certain foods absolutely do contribute significantly within such a varied pattern. Take kale, for example. Our sources highlight kale for its exceptionally high levels of antioxidants, fiber, and anti-inflammatory compounds, along with crucial vitamins like C and K, plus calcium and magnesium. These nutrients collectively support immune function, promote gut health, aid in disease prevention, and contribute to bone strength. But while kale is often singled out, the sources are really clear to point out all vegetables contribute significantly to a longer, healthier lifespan. It reinforces the importance of getting a wide variety of plant-based foods.
So kale's great, but eat your broccoli and spinach too.
Exactly. Kale's sirtuin content is also noted for its potential role in activating those longevity pathways, the SIRT1 pathway we discussed, involved in cellular repair and stress resistance. But again, it's part of the bigger picture. Blueberries are another often cited healthy food, sometimes given that superfood status. And they're recognized for some specific positive impacts. Their compounds can help block certain aspects of carbohydrate metabolism. They've been shown in some studies to reduce insulin resistance by up to 37% in certain studies focusing on type 2 diabetes patients.
That's quite significant.
It is. They can also help blood vessels relax, which contributes to reduced blood pressure. And they've been observed to reduce total and LDL cholesterol by as much as 12–15% in some studies. Again, these are fantastic specific benefits, but they're most effective when integrated as part of a broader, consistently healthy diet, not viewed as a standalone miracle cure.
Part of the pattern, not the whole pattern.
Precisely. We also hear a lot about intermittent fasting these days as a popular dietary pattern. And while it has been shown in some studies to activate key longevity-associated genes like SIRT1, that same gene activated by exercise, involved in cellular repair, some research indicates that simply limiting your daily eating window, say, to 8 hours, does not necessarily prevent weight gain over time or yield significant weight loss results for everyone.
Oh, interesting. So time-restricted eating alone might not be enough for weight loss.
Well, one study suggested that reducing the number of large meals consumed per day, or perhaps eating more frequent small meals, might actually be more impactful for weight management than just the timing window itself. It suggests that total caloric intake and meal composition often matter more than just the timing alone, at least specifically for weight control. The long-term longevity effects of various fasting protocols are still a very active area of research. The benefits might come more from the overall calorie reduction it often entails or the metabolic shifts it encourages during the fasting period, rather than just the rigid timing itself.
Okay, so another area where the pattern and overall intake seem key.
Exactly. And ultimately, the general dietary guidelines for Americans are remarkably consistent with all these longevity principles we've discussed. Consuming a diet rich in fruits, vegetables, whole grains, lean proteins, and healthy fats is really promoted as a crucial step to protect against chronic diseases and support brain function throughout life.
Hmm.
Patterns like the Mediterranean-style eating pattern or the DASH diet are explicitly recommended. And beyond just what you eat, mindfulness in eating, paying attention to your hunger and fullness cues, savoring meals, being present while you eat is also increasingly encouraged. It all points towards a holistic, pattern-based approach.
It definitely sounds like the overall pattern, the diversity of foods, and maybe even the mindful approach to how and what you eat are far more important than getting fixated on any single item. It's about building that robust, diverse foundation for health span day in and day out. So we've covered diet. Now let's pivot to movement exercise. For years, many of us have heard that old adage, no pain, no gain, when it comes to physical activity. It kind of pushes us towards our limits, often to the point of exhaustion, implying that only extreme effort yields real results. But does the scientific evidence truly support this extreme approach for longevity? Or is there maybe a more balanced, sustainable path that actually respects our body's limits and delivers better long-term results for healthy aging?
That no pain, no gain philosophy.
Well, while it might be motivating for, say, elite athletes striving for peak performance in a specific event, it can actually be quite detrimental when applied universally, especially if the goal is long-term longevity and sustained health span. The science really does challenge this notion of extreme, exhaustive exercise as the ultimate key. The concept of overtraining is critical here. Overtraining occurs when individuals ignore the signs that their body is being pushed too hard. Things like persistent fatigue that rest doesn't fix, decreased performance, maybe an elevated resting heart rate, irritability, increased susceptibility to colds and infections.
Basically feeling run down all the time from working out too much. Exactly. And they continue to train excessively without adequate recovery. This can lead to what some sources call severe damage to the body, impacting everything from your musculoskeletal system to your hormonal balance and immune function. Full recovery from true overtraining can be incredibly difficult, often requiring weeks or months of significantly reduced activity or even complete time off. And that clearly isn't conducive to consistent long-term health benefits. It's like hitting a wall instead of building endurance gradually and sustainably.
Right, burnout isn't healthy.
Not at all. Our sources really emphasize that healthy sleep, proper nutrition, and managing mental wellness are critical components of any effective training regimen, specifically to prevent overtraining. As one expert aptly puts it, you can have too much of a good thing, even when it comes to exercise, especially if it's maybe being used as the sole coping mechanism for stress, without balancing the physical demands with proper rest and recovery. It's all about finding that sustainable balance that builds resilience, not breaks it down.
Okay, so if it's not about pushing ourselves to the absolute physical limit every single day, what is the optimal exercise approach for healthy aging and longevity, according to the recent scientific studies? What should we realistically aim for to maximize benefits without risking that burnout, which can just derail our efforts completely?
The consensus from major health organizations like the American College of Sports Medicine, ACSM, the U.S. Department of Health and Human Services, HHS, and the CDC, points consistently towards moderate intensity and consistency as the real cornerstones of effective exercise for longevity. The general recommendations for older adults are quite straightforward and actually quite accessible for most people. They recommend at least 2 hours and 30 minutes, that's 150 minutes of moderate intensity aerobic activity per week.
Okay, 150 minutes moderate, like what?
Things like brisk walking, water aerobics, maybe even ballroom dancing or active gardening. Plus, crucially, muscle strengthening activities that work all major muscle groups for at least 2 days per week. Alternatively, you could opt for 1 hour and 15 minutes, 75 minutes of vigorous intensity aerobic activity per week.
Like jogging or running?
Exactly. Jogging, running, swimming laps. And again, that needs to be combined with at least 2 days of muscle strengthening exercises. And to clarify what we mean by intensity, you can use the widely accepted 10-point scale or just the simple talk test. Moderate intensity, that's maybe a 5 or 6 out of 10, or technically 3 to 5.9 METs, which stands for metabolic equivalence, means you're breathing harder, your heart is beating faster, but you can still talk comfortably. You probably couldn't sing a song.
Okay, can talk but not sing. Got it.
Right. Vigorous intensity, that's more like a 7 or 8 out of 10, or 6 or more METs, means you can't say more than a few words without pausing for breath. You're breathing hard and fast. The sources really stress that consistency is paramount. because the chronic adaptations your body makes to regular exercise, things like improved cardiovascular function, stronger muscles, better metabolic health, these are quickly lost if you stop training, even in people who are regularly active older adults. It truly is a use it or lose it scenario when it comes to fitness benefits.
So consistency beats occasional heroic efforts.
Absolutely. It's also important to note that for individuals who are perhaps highly deconditioned, functionally limited, or frail, the intensity and duration should start very low and progress very slowly. In some cases, muscle strengthening and balance training might even need to come before starting aerobic training for very frail individuals, just to ensure a safe and effective starting point builds confidence and ability.
That makes sense. Tailor it to the individual. What about the mix of intensity versus just volume?
That's a great question. A fascinating study published in the European Journal of Preventive Cardiology looks specifically at this interplay between intensity and volume of physical activity. It found that while both higher physical activity, PA, intensity and volume are generally associated with lower mortality risk for both all-cause and cardiovascular disease mortality, there was a crucial nuance. The health benefits of just doing a lot of volume might be primarily realized when you actually include activities of higher intensity within that volume.
So just walking slowly for hours might not be as good as adding some faster walking.
That's what it suggests. It implies that the intensity distribution of your physical activity might be more important for reducing mortality than just the sheer quantity or duration of PA alone. For example, the study even noted that accumulating your most intense activity in continuous bouts as short as 5 minutes, think maybe short, brisk walks up a hill, or a quick burst of jogging, might actually be more effective in reducing all-cause mortality than spreading out the same total duration of intense activity across the entire day in fragmented, less intense segments.
Interesting. So those short bursts of effort really count.
They seem to particularly count for maximizing health benefits, yes. And another massive study from the American Medical Association supports this general idea. It showed that adults who worked out 2 to 4 times more than the recommended amount of vigorous physical activity, so we're talking about 150 to maybe 299 minutes per week of vigorous activity, had a 21% to 23% lower risk of all-cause mortality and an impressive 27% to 32% lower risk of cardiovascular disease mortality compared to inactive individuals. The study concluded that a substantially lower risk of mortality was observed among individuals who had adequate levels of both long-term leisure time, moderate, and the vigorous physical activity. It really underscores that it's likely a combination of consistency and varied intensity that provides the most robust protection.
Okay, so aim for the baseline, but maybe add some vigorous activity if you can, and perhaps even more activity overall is beneficial.
That seems to be the direction the evidence points. But it's also really important to understand that while no amount of physical activity can literally stop the biological aging process itself or reliably extend maximal human lifespan beyond its theoretical upper limit.
Right. We can't live forever just by running.
Unfortunately not. But regular exercise does significantly increase average life expectancy. And it does this primarily by influencing chronic disease development, essentially reducing those secondary aging effects that often accompany unhealthy lifestyles, and crucially, by maintaining functional capacity. That's our ability to perform daily tasks, move independently, engage with the world as we age. And the good news is the body's adaptive capacity to exercise is remarkably well preserved right through the 7th decade of life and even beyond. It's truly never too late to start reaping significant benefits.
That's very encouraging. So what does this optimal exercise approach look like in practice? What are the key types of movement we should include?
Our sources provide really concrete examples of the types of movement that offer the greatest longevity benefits, often broken down into 4 key categories. First, aerobic or endurance activities. These involve sustained rhythmic movement of your large muscles. Think brisk walking, water aerobics, dancing, like ballroom or social dancing, jogging, running, cycling, whether stationary or outdoor, and even active gardening that gets your heart rate up. These are crucial for cardiovascular health and stamina.
Okay, the cardio part.
Exactly. Second, strength or resistance training. This is absolutely crucial for maintaining muscle mass, which naturally tends to decline with age, a condition called sarcopenia, but is vital for independence, metabolism, and maintaining energy levels. This can involve simple things like push-ups, and you can start on your knees or even against a wall if full push-ups are too challenging initially. Using resistance bands is great, weight machines, handheld weights, or even just functional daily activities like digging in the garden, lifting heavy objects, and carrying groceries count. The goal is typically 8-12 repetitions per exercise, aiming for a weight or resistance where the last few repetitions feel challenging, but doable with good form.
Building and maintaining muscle. Got it.
Third, balance training. This becomes increasingly critical as we age because balance typically decreases, significantly increasing the risk of falls, which can unfortunately have devastating consequences for older adults. Simple yet effective exercises include just standing on one foot while you brush your teeth. You can progress that by doing it with your eyes closed, or maybe standing on an uneven surface like a folded towel or a pillow to challenge your balance more. Even just standing up and sitting down repeatedly from a sturdy chair without using your hands for support is a great exercise because it strengthens the hip and thigh muscles crucial for mobility and stability. These balance exercises are recommended at least 3 days per week, especially for those identified as being at risk of falling. And structured programs like Tai Chi are consistently noted as particularly effective for reducing fall risk and improving overall balance.
Balance is key for independence.
Absolutely. And fourth, flexibility exercises. Simple stretches for major muscle groups like your hamstrings, calves, or triceps are important for maintaining range of motion and preventing stiffness or injury. These should ideally be performed at least 2 days per week at a moderate intensity, meaning you feel a gentle pull, not pain holding each stretch for maybe 15 to 30 seconds. It's generally best to do these after your aerobic or resistance workouts when your muscles are already warm and more pliable. Ultimately, the core message here is about building resilience through smart, consistent effort that really respects your body's signals, not burning yourself out through excessive training that leads to injury or exhaustion. And it's also worth noting that exercise training appears to significantly improve cognition and lower the risk of dementia. It can even help improve daily living activities for individuals who already have dementia. Furthermore, physical activity has been shown to buffer the negative effect of chronic stress on telomere length, those protective caps on our chromosomes, which is a direct link we'll explore more deeply right now.
So, it's about smart, consistent effort that builds resilience at a fundamental level, rather than burning ourselves out. This balanced approach actually helps our bodies right down at the cellular level, contributing to a longer, healthier life. That brings us very neatly to another major factor in our health, one that interacts profoundly with both diet and exercise. Stress. We often hear that stress is the enemy of longevity, the silent killer, something to be avoided at all costs. But is any stress inherently bad? Or is there actually a type of good stress that can make us stronger and more resilient, almost like an internal workout for our systems?
That's a crucial distinction to make, and the science is quite clear that no, not all stress is created equal. We absolutely need to redefine the role of stress by introducing the concepts of eustress versus distress. Eustress is exactly what you're hinting at. It's the positive, beneficial form of stress. It's the kind of stress that encourages us to face challenges with a sense of purpose, vigor, and engagement. Think about when you set a challenging but achievable goal, like maybe training for a 5K race or mastering a new skill for work or a hobby or taking on a demanding but rewarding project. The stress you feel in that pursuit when it's effectively managed and ultimately leads to achievement brings a profound sense of accomplishment, satisfaction, and personal growth.
Like the stress that helps you perform better.
Exactly. This is good stress. It motivates us, it sharpens our focus, and it actively builds resilience, both mentally and physically. Distress, on the other hand, is the type of stress we usually think of negatively, and rightly so. This is what happens when stress becomes chronic, overwhelming, or simply unmanageable. It leaves you feeling drained, exhausted, maybe cynical, and leads to decreased performance across all areas of your life. Ultimately, unresolved distress profoundly impacts your mental and physical health in detrimental ways. It's really the difference between, say, a challenging but invigorating sprint and being stuck in a perpetual, exhausting marathon with absolutely no finish line in sight. Okay, eustress good, distress bad. Makes sense. What about this idea of stress making us stronger? Right, this idea of good stress is beautifully captured by a fascinating biological concept called hormesis. Hormesis is a biological phenomenon where exposure to low doses of a stressor or even a toxin, something that would be harmful at high doses, actually induces a beneficial adaptive response in the organism. It improves the organism's overall health, resilience, and function. It's truly the what doesn't kill us makes us stronger principle playing out right at a biological cellular level. Our bodies seem designed to adapt and thrive when presented with the right amount and type of challenge.
Interesting. So, what are some examples of these hormetic stressors relevant to longevity?
We can see hormesis in action in several powerful ways. First, exercise itself is a classic hormetic stressor, as we were just discussing. Physical activity induces a mild, transient stress on the body. There's a temporary breakdown of muscle fibers, a brief increase in inflammation, a spike in heart rate. But this controlled stress triggers powerful adaptive responses within our cells. It leads to improved cellular function, enhanced cardiovascular health, stronger muscles, and overall greater resilience. Your body gets stronger, more efficient, and more resilient precisely because it had to recover from that controlled, intermittent challenge.
Okay, so exercise fits this model perfectly. What else?
Second, calorie restriction or intermittent fasting. Short, controlled periods of reduced calorie intake or fasting, as we touched on briefly in the nutrition section, are also considered powerful hormetic stressors. These mild metabolic challenges have been shown to activate key longevity-associated genes like SIRT1. Remember, SIRT1 is part of that family of sirtuin proteins involved in crucial cellular processes like DNA repair, stress resistance, metabolism, and inflammation control. By activating SIRT1, calorie restriction seems to mimic beneficial stress responses, enhancing cellular cleanup processes like autophagy and improving mitochondrial efficiency. It's not about starvation, but about sending a signal of mild, temporary challenge that promotes cellular resilience.
Right, stimulating those repair pathways.
Exactly. And third, another popular one these days is cold exposure. Deliberate, controlled cold exposure, such as taking a cold shower or maybe brief ice baths, is a potent hormetic stressor. When exposed to cold, your body responds by activating and recruiting what's called brown fat, or brown adipose tissue. Unlike white fat, which primarily stores energy, brown fat actively generates heat by burning calories. Studies have consistently shown that individuals with higher levels of active brown fat tend to enjoy significant health advantages, including a lower prevalence of type 2 diabetes and a healthier balance of cholesterol levels. So a short, controlled burst of cold can actually trigger beneficial metabolic adaptations and enhance cellular resilience. The absolute key with all hormetic practices, however, is moderation and gradual adaptation. You want to provide a beneficial stimulus, not overwhelm the system to the point where it crosses over into distress.
That's incredible that our bodies are actually designed to respond and adapt positively to these controlled challenges. It completely reframes how we might think about pushing our boundaries, but in healthy, manageable ways. But what happens when stress does become chronic? When it goes way beyond this beneficial hormetic threshold and just turns into overwhelming, unresolved distress? What are the real long-term dangers of that kind of persistent negative stress?
When stress becomes chronic and unresolved, it leads to something far more insidious than just feeling bad. Scientists sometimes call this state allostatic overload. This isn't just about feeling overwhelmed psychologically. It directly and powerfully accelerates the aging process through highly damaging biological mechanisms. One of the most significant of these mechanisms is what we now call inflammaging.
Inflammaging, like inflammation and aging combined.
Exactly. Normally, after a temporary stress response, our body's primary stress hormone, cortisol, acts to suppress inflammation, helping bring the system back into balance. It's an anti-inflammatory hormone in the short term. But with chronic psychological stress, our body's tissues can actually become resistant to cortisol's signals, much like cells can become resistant to insulin in type 2 diabetes.
So the stress signal keeps firing, but the off switch doesn't work properly.
Precisely. This leads to an overproduction of pro-inflammatory cytokines. These are signaling molecules that constantly fan the flames of inflammation, creating a persistent, systemic, low-grade inflammatory environment throughout the entire body. This inflammaging is now widely recognized as a known driver of nearly every major age-related disease, including cardiovascular disease, type 2 diabetes, neurodegenerative conditions like Alzheimer's, and even certain cancers. It literally provides a mechanistic bridge connecting the psychological experience of chronic stress to the physical pathologies of aging.
That's a really direct and damaging link.
It is. And what's particularly fascinating, and maybe a bit sobering, is that while inflammaging is widely considered a hallmark of aging in industrialized nations, studies comparing these populations with indigenous non-industrialized groups like the Tsimane in Bolivia or the Orang Asli in Malaysia suggest it's not actually universal to human aging. In these non-industrialized groups, inflammation levels seem to be driven much more by things like acute infections rather than by chronological age itself. This suggests that perhaps our modern industrialized lifestyles, with their inherent chronic stressors, might be significantly exacerbating this age-related inflammation.
Wow, so it might be more a product of modern life than just aging itself.
That's an active area of investigation. Beyond inflammaging, chronic stress also links directly to telomere shortening.
Telomeres, those are the caps on the ends of our chromosomes, right?
Exactly, like the plastic tips on shoelaces that prevent them from fraying. They naturally shorten a little bit each time a cell divides, which is a normal part of the aging process. Yeah. However, stress-induced telomere damage is now identified as an important pathway to accelerated disease and premature aging. Mediators of stress, things like glucocorticoids, the class of hormones cortisol belongs to, reactive oxygen species, ROS, which are unstable molecules that cause cellular damage, and inflammation itself, they're all interconnected in a kind of vicious cycle. They reinforce each other in positive feedback loops, essentially accelerating cellular aging and speeding up that telomere shortening process. So chronic stress isn't just a feeling, it's a profound molecular assault on your fundamental cellular longevity mechanisms.
That makes it incredibly clear. Actively managing chronic stress is absolutely crucial for healthy aging. It's not just about feeling better mentally, which is important, but literally protecting our bodies at a deep cellular level, guarding against things like inflammaging and premature telomere damage. So, what actionable, practical strategies can our listener adopt to shift towards positive adaptation and minimize that harmful distress in their daily lives?
You're absolutely right. It's about actively managing, not just trying to avoid stress, because some stress is unavoidable and even necessary. One of the most impactful and scientifically validated strategies is embracing mindfulness and meditation. Mindfulness meditation helps interrupt that negative stress cycle. It allows individuals to pause, observe their thoughts and feelings without judgment, and then respond thoughtfully instead of just reacting impulsively or automatically. It's really about deliberately practicing being in the present moment in an open, receptive, non-judgmental way. This actually trains your brain over time to step out of that habitual fight-or-flight stress response.
Learning to pause before reacting.
Exactly. And deep breathing techniques are often a cornerstone of this practice, offering immediate physiological benefits. You can try diaphragmatic breathing, also known as belly breathing. You sit or lie down comfortably, place one hand on your chest and the other on your abdomen. Then inhale slowly and deeply through your nose, maybe counting to 10, really focusing on drawing the breath down from your abdomen so your belly rises, not just your chest. Then exhale slowly through your nose at the same pace, perhaps counting to 10 again, feeling your belly fall. Even just a single session of this deep, slow diaphragmatic breathing has been consistently found to reduce blood pressure and heart rate, sending a signal to your nervous system that you are safe and can relax.
Simple but powerful.
Very. Another effective technique is the 4-7-8 breath, which was developed by Dr. Andrew Weil. For this, you place the tip of your tongue just behind your upper front teeth. You exhale fully through your mouth, making a whoosh sound. Then close your mouth and inhale quietly through your nose to a mental count of 4. Hold your breath for a count of 7. Finally, exhale completely through your mouth, again with that whoosh sound, for a count of 8. You repeat this cycle maybe 3 more times. This specific technique is designed to promote profound relaxation and can even be helpful for falling asleep.
Okay, focused breathing techniques. What else?
Another vital strategy, one that's often overlooked perhaps in our more individualistic society, is to lean on your support system and actively cultivate strong social connections. As we age, having a robust social support network actually becomes even more essential for navigating life's inevitable challenges. Social connections play a key role in our emotional resilience and significantly reduce feelings of isolation and loneliness. And this is incredibly important because loneliness and social isolation aren't just unpleasant emotional states. They're directly linked to increased stress levels, higher rates of chronic inflammation, weakened immune function, and a higher risk of serious conditions like dementia, cardiovascular disease, and even premature mortality.
So being connected is literally good for your physical health.
Absolutely. Research consistently shows that strong social support boosts resilience and helps older adults manage stress much more effectively. Staying socially active, whether that's through regular phone calls or video chats with family and friends, joining local community groups, volunteering, or participating in shared hobbies, provides vital emotional support, fosters a profound sense of belonging, and often encourages positive health behaviors as well. Investing time and energy in meaningful relationships isn't just about social fulfillment. The science suggests it's a fundamental strategy for optimal health and well-being throughout life.
Makes sense. So mindfulness connection, what about broader approaches?
Right. Integrating holistic approaches into your daily life is key for comprehensive stress management. This definitely includes consistently engaging in regular physical activity, which we've just highlighted as a powerful stress reducer in itself, releasing endorphins and improving mood. And of course, maintaining a healthy, balanced diet, choosing whole, nutrient-dense foods, as we discussed earlier. These foundational habits actively support your body's baseline ability to cope with stress. Additionally, exploring spiritual practices can foster a sense of peace and purpose, which can be incredibly grounding. This might be through meditation or yoga, spending mindful time in nature, or perhaps engaging with a faith community if that resonates with you. It's also critical to proactively reflect on and communicate your own emotional and physical needs to your family and friends. Sometimes just voicing them helps. And don't hesitate to connect with local supports and services that might be available in your community. Things like a local commission on aging, religious organizations, or community centers often offer valuable resources for housing, financial assistance, caregiver support, kinship care, or even bereavement support if needed. All of these strategies really empower you to manage stress proactively, rather than allowing it to build up and overwhelm your system, potentially accelerating the aging process.
That's a really comprehensive toolkit. So, stress isn't uniformly bad, but learning to harness that good stress, the eustress, and actively manage the chronic distress is absolutely vital. This balanced approach helps our bodies right down at the cellular level, enhancing our resilience and directly impacting our longevity. This brings us to another area where, let's be honest, many people look for a quick fix, maybe a silver bullet, if you will, supplements. So many people look for that miracle pill to unlock longevity, a simple shortcut to a longer, healthier life. We've seen how impactful lifestyle choices like diet and exercise and stress management can be, but what does the science really say about these heavily marketed anti-aging supplements? Are they the answer? Are they the fountain of youth in a bottle, as some of the marketing might suggest?
The allure of a miracle pill for longevity is undeniably strong. It taps into a very deep human desire. But the science around anti-aging supplements really requires a significant dose of reality and maybe some critical evaluation from consumers. First, it's really crucial to understand how these products are regulated, or often how they're not regulated as strictly as prescription or even over-the-counter medicines. The FDA and the FTC in the US have guidelines. They clearly state that if a dietary supplement makes a claim, either explicitly or implicitly, for the treatment, prevention, or cure of a specific disease, it would be subject to regulation as a drug, requiring rigorous proof of efficacy and safety.
But many supplements don't claim to cure diseases, right? They use vaguer language.
It's exactly. Many sidestep this by making more general structure-function claims, or claims about supporting general health or well-being. The fundamental principle for consumers, though, should be that they should not be looking to dietary supplements to treat diagnosed medical conditions. Now, dietary supplements can certainly help consumers improve or maintain their overall health, maybe support a healthy lifestyle, or meet daily requirements of essential nutrients if their diet is lacking. Think calcium and vitamin D for bone health, or maybe fiber supplements for digestion. However, the FDA is clear that supplements should not take the place of the variety of foods that are important for a healthy diet. You can't supplement your way out of a poor diet.
Okay, there's supplements, not replacements.
Right. Furthermore, the FTC requires that companies have competent and reliable scientific evidence to back up any claims they make about their products. And importantly, claims that, if unfounded, could present a substantial risk of injury to consumer health or safety, especially if relying on the supplement might lead consumers to forego other validated medical treatments or try to self-medicate for serious conditions, will be held to a higher level of scientific proof. There's also a crucial warning that applies to combination supplements or cocktails containing various ingredients. Interactions between multiple herbal products or compounds might alter their effects or their safety profile in unpredictable ways. And just because individual ingredients might have some safety studies doesn't mean the combination product is safe or effective. This creates a regulatory and safety gray area that consumers really must navigate with caution.
So it's complex, and the burden of proof isn't always as high as we might assume. What about some specific popular anti-aging supplements, like NAD plus boosters?
Right, let's discuss some common ones that generate significant hype. NAD plus boosting compounds like nicotinamide riboside, NR, or nicotinamide mononucleotide, NMN, are very popular right now. And it's true that NAD+, that's nicotinamide adenine dinucleotide, is a crucial coenzyme involved in countless vital cellular processes like energy production and DNA repair. It's also true that NAD+ levels do tend to decline with advancing age and in many disease states. Now, preclinical studies, mostly in various lab models from yeast to mice, suggest that boosting NAD+ abundance using these precursors like NR or NMN can have profound effects on metabolism, cellular repair, and even lifespan in these organisms.
Okay, promising in animal models. What about humans?
That's where it gets less clear. In humans, supplementation with these compounds appears to be generally safe and tolerable, and studies do show they can successfully increase NAD+ and related metabolites in multiple tissues, like blood and muscle. However, and this is a really critical distinction, the clinical evidence that simply raising NAD plus concentrations can definitively improve physiological function in healthy humans in a way that translates to meaningful longevity benefits is currently unclear.
So levels go up, but we don't know if it actually does much for healthy aging yet.
That's pretty much the state of the science right now. Many human studies have had small sample sizes, and the dosing regimens and study durations have varied widely, which limits our ability to clearly interpret the results for broad physiological outcomes in healthy people. For instance, one notable trial in patients with ALS, Lou Gehrig's disease, showed some potential functional improvements with a combination of NR plus another compound called pterostildine. But crucially, NAD plus levels weren't actually measured in those specific patients in that trial, making it hard to definitively attribute the improvements directly to NAD plus increases versus other effects. So it's a very active and genuinely promising area of biomedical research, absolutely. But it's important to be clear. It is not a proven broad-spectrum longevity solution for healthy humans yet. We really need much more robust, large-scale, long-term human trials before we can make those kinds of claims.
Okay, promising but needs more proof. What about collagen? That's everywhere too.
Yes, collagen is incredibly popular, especially for skin health. Collagen is a vital protein for skin elasticity, joint health, and connective tissues throughout our body. As we age, our natural collagen production does slow down, and that contributes to visible signs of aging, like wrinkles and maybe sagging skin. Supplementation with collagen peptides has been shown in several studies to improve skin hydration, elasticity, and roughness, and it can reduce the appearance of wrinkles.
So it does work for skin.
For improving the appearance of skin, the evidence is reasonably good. However, it's really important to recognize that collagen supplementation primarily addresses cosmetic symptoms of aging, like skin appearance or maybe joint comfort for some people. It doesn't appear to target the fundamental biological aging process itself at a cellular level or extend lifespan in the way that, say, geroscience aims to. It's more about appearance and symptom management, not fundamental cellular longevity.
Got it. And antioxidants, vitamin C, E, green tea extracts.
Antioxidants are another huge category, popular for decades as anti-aging agents. The underlying theory makes sense. Free radicals, which are unstable molecules generated by metabolism and environmental factors, cause cellular damage, oxidative stress, and this damage is thought to accelerate aging. And indeed, things like habitual green tea intake are epidemiologically linked, meaning in population studies, to a reduced risk of various diseases and overall mortality. And compounds like EGCG from green tea may improve mitochondrial function in lab studies. However, studies on taking systemic antioxidant supplements like high-dose vitamin C or E pills in humans have not always shown consistent benefits for longevity or preventing age-related diseases. In fact, some large trials have been quite disappointing, showing no benefit or even potential harm in certain contexts.
Really? So more isn't always better with antioxidants?
It seems not, at least not an isolated high-dose supplement form for everyone. The body has its own complex antioxidant systems, and flooding it with external ones might disrupt that balance. Also, for topical application like vitamin C serums for the skin, the substance itself is often very unstable. It reacts immediately with oxygen in the air, making effective formulations difficult. Plus, its levels in the skin can be significantly depleted by environmental factors. UV exposure can decrease skin vitamin C by 30%, and city pollution by a staggering 55%. Most vitamin E research supporting anti-aging benefits is still primarily animal-based, though some human studies do link it to potentially improving immune function in the elderly. And many lab studies actually found no effect of various antioxidants on cell proliferation and culture, making the underlying processes and the broad efficacy of just supplementing with antioxidants somewhat controversial. While there are newer mitochondria-targeted antioxidants being developed, their effects on lifespan, even in mice, have been pretty marginal so far. And as we mentioned earlier with acai, despite its antioxidant properties on paper, the direct human evidence for significant longevity benefits remains limited and inconsistent.
So antioxidants are complex, and supplements might not be the simple answer.
It appears that way. This brings us to another really powerful, often underestimated factor influencing the perceived benefits of many supplements: the placebo effect.
Ah, the power of belief.
Absolutely. The placebo effect is defined as a beneficial physical or psychological change in health that results from a person's belief in a treatment, rather than from any specific physiological effect of the treatment itself. What's truly fascinating is that the placebo effect can occur even when people are told they are taking a placebo. This is called open-label placebo research, and it still shows effects.
Even when they know it's fake, how does that work?
It's thought to be due to a combination of factors. It could be the feeling of hope and the positive anticipation of relief that comes just from participating in a study or trying something new. It could be the expectation, conditioning we expect pills to make us feel better. It could even be the ritual of the physical act of pill taking itself. Opening the bottle, swallowing the capsule that triggers a beneficial response. And sometimes, it's just natural fluctuations in symptoms. Pain or discomfort might coincidentally decrease while someone happens to be taking the placebo, and they attribute the improvement to the pill. It's a crucial reason why many people genuinely feel better when taking certain supplements, even if those supplements lack direct, specific biological action on their underlying condition or the aging process itself. It really highlights the profound and complex connection between our mind and our body.
That puts a lot of those miracle claims and maybe even personal anecdotes into a very clear perspective. The mind is powerful. So if we shouldn't necessarily rely on unproven supplements or chase quick fixes, where is the actual core scientific frontier? Where is the real progress being made in understanding and potentially impacting aging at a truly fundamental level, beyond just managing symptoms or relying on belief?
The real scientific frontier, where the most promising and rigorous breakthroughs in extending healthy longevity are being sought, lies in this burgeoning field called geroscience. Geroscience is a highly interdisciplinary field. It sits right at the intersection of basic aging research and disease pathology. Instead of just studying and treating individual age-related diseases like heart disease or diabetes or Alzheimer's in isolation,
Yeah.
as medicine has traditionally done.
Right, treating them one by one as they pop up.
Exactly. Geroscience aims to unravel the intricate relationship between the fundamental biological aging process itself and the development, the pathogenesis of all these age-related diseases. The core hypothesis of geroscience is that if we can understand and target the root mechanisms of aging, we might be able to simultaneously delay or prevent multiple chronic diseases that tend to cluster together in later life, thereby extending health spans significantly.
Tackling the root cause, not just the symptoms or individual diseases.
That's the goal. Geroscience focuses on understanding and potentially manipulating these fundamental cellular and molecular mechanisms that underpin biological aging. Key areas of intense research include, first, cellular senescence. This is the process where cells, after accumulating damage or reaching a certain limit, stop dividing. But critically, they don't necessarily die. Instead, they can enter this senescent state where they become metabolically active but dysfunctional. They start secreting a cocktail of pro-inflammatory molecules collectively called the senescence-associated secretory phenotypes, or SAP, that can spread damage to neighboring cells, contribute to chronic systemic inflammation, that inflammaging we talked about, and promote tissue dysfunction, thereby accelerating the aging process.
So these zombie cells are causing problems.
That's a common analogy, yes. A core anti-aging strategy being explored within geroscience is the targeted clearance of these senescent cells using drugs called senolytics, or potentially finding ways to restore their healthy function instead. Second, mitochondrial dysfunction. Mitochondria, as we mentioned, are the powerhouses of our cells, responsible for producing the vast majority of cellular energy, ATP. As we age, mitochondrial function can decline, leading to impaired energy production, increased oxidative stress from within the cell, and accumulation of cellular damage, all considered hallmarks of aging. Geroscience research is heavily focused on finding ways to optimize cellular metabolism and maintain mitochondrial health through various interventions, from lifestyle approaches to potential pharmaceuticals.
Keeping the cellular engines running smoothly.
Right. And third, DNA damage and epigenetic alterations. We discussed epigenetics earlier, and it remains an absolute central pillar of geroscience. Over time, our cells inevitably accumulate some DNA damage, and those progressive epigenetic changes we talked about, alterations in methylation and histone modifications, continue to occur, leading to dysregulated gene expression patterns characteristic of aging. Since, unlike permanent genomic mutations in the DNA sequence, epigenetic alterations can potentially be reversed, they represent a significant and highly promising target for interventions aimed at delaying aging and promoting healthier gene expression patterns later in life.
So senescence, mitochondria, epigenetics, these are the core targets.
Those are certainly some of the major ones, yes. And there are even more emerging, highly sophisticated interventions being explored within geroscience, like specific immune cell therapies or stem cell-based interventions. For example, mesenchymal stem cells, or MSCs, are a type of adult stem cell that have known immunomodulatory, anti-inflammatory, and regenerative properties. They have actually shown promising initial clinical efficacy in treating aging-related frailty in rigorous human clinical trials. These studies, which are multi-phase, phase 1, 2, and II, have shown that infusions of MSCs can improve important functional metrics like how far frail older adults can walk, reduce levels of key inflammatory markers like TNF-alpha, and show improvements in cognitive status and overall quality of life for these individuals. MSC-derived exosomes, tiny vesicles released by stem cells containing bioactive molecules, are also a very promising area of therapeutic research.
Wow, so actual cellular therapies are being tested?
They are. But it's absolutely crucial to understand that these are complex, advanced therapeutic strategies currently undergoing rigorous clinical investigation in controlled medical settings. They represent cutting-edge medical interventions being carefully developed by the scientific community. They are not simple over-the-counter pills or injections you can just pick up at a pharmacy or order online. This is where the true methodical scientific effort to potentially extend healthy human longevity is focused on understanding and targeting these fundamental biological processes.
That really puts the focus back squarely on foundational biological processes, deep understanding, and rigorous scientific inquiry, rather than just chasing quick fixes or believing the marketing hype. It's a completely different and much more grounded paradigm. So what does this all mean for you, our listener, as you navigate your own health journey day by day?
We've really gone from that ingrained idea of a static, almost unchangeable genetic destiny to a much more dynamic, evolving landscape where your daily choices are constantly influencing your biology, right down to the very expression of your genes. Exactly. To just summarize the key takeaways from our deep dive today. Firstly, while our genes certainly play a role in our longevity, the evidence strongly suggests that lifestyle and environmental factors, the choices we make about our diet, how physically active we are, how we manage stress, are vastly more influential in determining both our total lifespan and, perhaps more importantly, our health span. We have immense agency here.
We're more in the driver's seat than we thought.
Much more. Secondly, when it comes to nutrition, focusing on a balanced, diverse dietary pattern, well exemplified by something like the Mediterranean diet, provides holistic and scientifically supported benefits for overall well-being and disease prevention. This pattern-based approach, rich in whole foods and ideally incorporating mindful eating, far outweighs the often exaggerated claims and frequently unproven benefits of fixating on any single superfood.
Pattern over magic bullets.
All right. Thirdly, optimal exercise for longevity isn't about extreme, exhaustive effort or blindly following a no pain, no gain mantra. It's really about consistent, moderate to vigorous physical activity combined with essential strength, balance, and flexibility training, always ensuring you allow for crucial recovery time to prevent overtraining and build genuine, sustainable resilience throughout your life.
Smart, consistent effort.
Fourth, stress isn't uniformly bad. Learning to distinguish beneficial eustress, those controlled challenges like hormetic stressors that can actually make us stronger, from detrimental distress, that chronic unresolved stress that leads to damaging, inflammatory, and accelerated cellular aging, is vital. Proactive stress management through powerful tools like mindfulness, deep breathing techniques, and cultivating strong social connections is absolutely key to healthy aging at a fundamental biological level.
Manage stress, don't just avoid it.
Precisely. And finally, those tempting miracle supplements often lack robust human evidence to support their broad longevity claims. Their perceived benefits can frequently be attributed, at least in part, to the powerful placebo effect, which, while a real phenomenon, does not indicate a true biological anti-aging mechanism from the pill itself. True breakthroughs in extending healthy longevity are being actively sought through fundamental scientific principles and advanced research in fields like geroscience, targeting the very cellular mechanisms of aging with rigorous, evidence-based approaches, not through readily available pills promising a quick fix.
It's crystal clear. Your choices today, the ones you make consistently, are actively shaping your cellular future, right down to how your genes are expressed. This understanding is profoundly empowering, isn't it? Because it means you're not just a passive recipient of your genetic blueprint, but an active, daily participant in your own longevity journey. It's really about building that solid foundation of healthy habits that compound positively over time.
So, perhaps a final thought for you to mull over. Considering the powerful and often quite subtle ways our daily environment and choices shape our genes and cellular health, what one small, consistent habit could you perhaps introduce, starting today, that might just ripple outwards into decades of healthier living?
That's a great question to reflect on and a perfect challenge to end with. Perhaps it's exploring one of those specific hormetic stressors that resonates with you, like trying a short cold shower finish, or maybe just committing to trying one of those deep breathing techniques for 5 minutes a day this week. We really encourage you to dig deeper into any of these areas that piqued your interest during our chat. We hope you've enjoyed this deep dive into unlocking your longevity potential beyond your genes. Join us next time for another fascinating exploration.